Hi everybody, today is April 13th and 2013. This is William and he is the soil expert and we'll be discussing some very interesting information. William, why don't you just tell us what you've got here and tell us about some soil.
Okay, well this is what I have here. This is a basic greenhouse soil. It's a greenhouse soil mixture. It probably goes back 100 years, although in the old days they pretty much used peat, and instead I use coconut peat, which is a more stable pH. It's less acidic, and some folks believe it's more environmentally sustainable. The secret ingredient I add to this mixture is comes from northern Minnesota and North Dakota, and it's a humus that they think is up to 1,000,000 years old, that is full of natural humates, which include humic acid and fulvic acid. So the most important thing about humates to know is that it takes actually all three of these in an organic soil system for plants to access nutrients in areas of higher concentration.
Tell us about what it takes for the humates to be active. In other words, how do you say that this soil is more energized than another typical soil you'd buy, say, at the garden center?
Well, the difference. Most of this soil doesn't have humate at all, but the humus part of it has a humus that you'd find in any kind of soil, any kind of normal, any kind of very dense, like forest soil. The composition should be about equal to it. What's difference between an organic system soil and a potting soil you would buy is the biological processes involved that take thousands and thousands of years to form humic compounds, the most complex compounds on the planet. Now you will find products that are humates that are made from leonardite coal. Leonardite coal comes from the Carboniferous era. It's about 200 million years old. And those humates have become very, very stable over a long period of time. These are stable compounds to begin with, but they become more and more stable over time.
Mm-hmm.
So here you have fresh compost, which has humus in it. It has some humus. 4% would be about the richest. You have forest soils, which will run 4 to up to 20% in a wetland type environment. And then you'll have Carboniferous coal, which could run up to 80% humates. The difference, how humates work, is that they're these complex carbon compounds that are very large molecules. They have a lot of different atoms in them, and they have electrical charges all the way around the molecule. They have negative and positive points for cations and anions. That's your micro and macronutrients in the soil to loosely adhere to. They also adhere to each other, the humates will, and so that makes, what that does is that creates in the soil what are called macro aggregates. In between, there'll be these balls, kind of think of them as clumps. In between those, there'll be water, air, and the hyphae of various fungi.
Okay, now is the soil, you mentioned about it having the ability to be regenerated. You just add a little compost. What is the ratio of that, and how does that work?
In my soil here, the compost, what I do is I run about 20% screened compost.
Okay.
Is part of my soil, and that's a typical mixture for making plugs and potting soil. Some people will put a little bit more, but it's important to not put. You don't want it to be too rich.
All right.
What's most important is drainage, water retention, and airspace, not nutrients as people would think.
Okay, good. Now this adds a lot of space, a lot of air. In other words, this mixture, this combination you're using. Tell us a little bit about then how this soil can be supported in its current, what's called optimal state. In other words, if you were to just give me your feedback on that.
Well, the best thing to do if you're planting plants is to make like a compost tea. My recommendation would be you want to feed your beneficial bacteria that are already in the soil, and things that'll feed those are compost type teas or a manure tea. Also molasses.
What is the ratio used for molasses?
You want to put 3 tablespoons to a gallon.
Okay.
And you only really want to mix, if you're mixing with a compost tea, you only want it to be about 10% of your total mixture.
Got it. Okay, and the compost tea, the worm collection. Do you sell this tea, or do you make the tea and then give it to people?
I will be making it and
You will
selling
be making
compost teas of various kinds, tailored to individual growers' needs, because different plants have different needs. I mean, some flowers like roses tend to be more acidic. The most sensitive of which would be cucumbers and tomatoes, and those are typically a heavy feeder.
So let me see if I can distill some of this information. If you're saying then that you're creating more space with this soil, in other words, moisture can be transferred. There's also a charge involved, and that charge is appropriate for seed starting with this, for example, and then potting soil.
Right, the humic compounds in there, they have the electrical charge that they have is called a paramagnetic dipole moment. It's a big word, but what it basically means to a farmer like me is that it means that it has electrochemical conductivity.
Right.
It allows things to become available. Like sometimes you'll see your leaves turning yellow in your field, and that's what's called chlorosis.
Right.
And that's where the inability of the plant to uptake iron. Well, if you were to put humates on that, you'll see that process revert. It'll start uptaking iron. It'll start uptaking iron, and the yellowness will go away immediately. Stuff like this will happen in a matter of hours.
So, and you mentioned about insolubility, that there is a difference, that there's a marketed version of humate. Go ahead.
Well, okay, most humate products are made from leonardite coal, which is 200 million years old. It's from the Carboniferous era. What happened is those humates have lost their paramagnetic dipole moment somewhat.
Okay.
They've bonded to those electrical bonds have bonded to the minerals in the soil and become stable. It's what they call brown coal, leonardite.
Okay.
And it's basically somewhere where peat is starting to turn into coal.
So if you're using, say for example, the biochar, we're putting charcoal into the soil, and you gave me that wonderful story about the cottonwoods burning, and you're throwing it all over the land that you were doing some alfalfa growing and other legumes. What was the change? You saw that the coal placed there.
With charcoal. Well, charcoal, how it actually works is when you incorporate charcoal into a soil system, an ancient farming technique, used by many indigenous peoples. The charcoal, unlike ash, which is alkaline, charcoal is fairly pH stable, but what it has is a lot of holes, and it has water retention ability. And the holes actually allow a toehold for microlife to get a hold of, and it helps the soil retain water. It's also stable carbon. And this biological activity is what helps form humus over time. It's the dying bodies, about 50% of which are of fungi, and then the other 50% are the other citizens of the soil food web, the bacteria, nematodes, arthropods, and so on. So biochar, when you incorporate charcoal into your garden, like me, I just burn the stalks of my weeds and then put them out with the hose, and I leave that in my furrows.
Okay.
It's kind of a mulch, and that over time, that little bit of charcoal being added slowly improves the formation of more stable carbon.
Understood. Okay, so that's an important point, because people are asking about because we're in a dry environment here. How does water get retained in the soil, and there's space? So we've got three things I'm seeing. And there's an energy transfer, there's a moisture component, and of course this ability, retaining moisture, that is. And then there's this ability to keep the nutrients going into the plant by way of the environment that you've created with this humate, and the ability that you made this. We'll call it a recipe, okay, of 20% of this mixture from the Dakota humates. Is that right? 20%.
The product is called Dakota Soil and Plant Enhancer that I use.
Okay.
And that's additive. That's one of the additives to my soil mixture, it's unique in its source. There are other sources. There are a few people who are making like a humic compost.
Okay.
and one is out of New Mexico. But there's very few sources of humates unless you're to do it in your own garden.
I see.
And which is making compost, where you're combusting the carbon and allowing it to become more stable, establishing a soil food web. The soil food web will form the humic compounds on its own.
Excellent. And can you tell us a little bit about some of your experiences after you've started using the soil, as far as growing? Tell us what it looks like, from year to year. Are you getting like it maturing about 2 weeks early? I mentioned I had one plant that had the biochar in it and good quality soil, and it grew 300 plants. 300 tomato, on the plant,
right.
One plant. Tell me about what your experience has been.
Well, my experience in using the fertility amendment that I add to this greenhouse soil, for the most part, 80 to 90% of it is your typical, it's a typical potting soil mix recipe that any organic greenhouse it's in production. Probably, they use this or something similar.
And that means any seeds. We're talking, anything from squash to starting wheatgrass or something.
Right. That it's fairly accurate. This would be something, and they probably add a little bit of topsoil into this mixture too.
I see.
And but the fertility product that I'm using, which is high in humic compounds and active bacteria and some active fungi, what I've been finding is that in every plant I've tried, with legumes like soybeans and alfalfa, and then it's been tested with chrysanthemums and other products, we're finding 4 times the root growth in the first 2 weeks.
Really? That's
4 times
amazing.
the root mass. And I wish I had pictures here to show you.
No, that'll be the next one. We'll follow up on this. We'll get a part 2.
You get about 4 times the root growth. And I have a tomato grower who's using a liquid amendment product that I use, and he's saying that every one of his plants has a super bloom on it. Normally he only has 1 or 2 of his plants, and the super blooms are what he say make 5 and 6 pound tomatoes. That's something I'm not.
Oh, that's amazing.
And
do they taste good though?
And that's because of increased cation and anion exchange.
But the moisture has a lot to do with this also. Tell me if there's any purifying properties. In a lot of the soils, people are concerned about contamination in their soil. They've had, for example, fertilizers that nitrogen fertilizers, and Roundup was used on some of the different fields. Is there some kind of way of neutralizing some of the negative effects on the soil in areas with using, say for example, soil that you're using or other techniques?
Repeat that question again. That was a
little bit. In other words, if soil has been either overused.
Yeah, it's losing its mineralization.
It's losing its mineralization, or some soils have to wait, for example, 3 years before they're able to be used again because they can't be called organic.
Oh, I see. Yeah, the organic certification program requires you to have 3 years, 3 total growing seasons to become certified.
I see. Yeah.
And that in and of itself is, really the difference between conventional and organic is less than people think. Most of our soils have lost mineral content, or losing mineral content through various reasons, whether that's over fertilization or it's wind and water erosion.
Okay.
The best way to reverse that process is establishing your soil food web again, which includes the entire biology, by having, whether it's a conventional or organic farmer, it really makes no difference.
Okay.
It's just being able to use your tillage practices appropriately.
And do you introduce this, how much of that soil would go to a cubic foot of soil that would be in your garden? Would you, in other words, after you got it started in the greenhouse, would you mix some of that soil in with your existing soil?
This is basically a potting mix, and to mix soil in your garden, it's always more practical than to mix the raw materials and the organic matter in as you go.
I see.
It's always, from an economic standpoint.
I see. Okay, excellent. Well, I think that's going to do it for this particular segment. We'll do a part 2 when I come back.
Okay, great.
And then we'll follow up. I'll have more questions for you, that's for sure.
Okay, thanks, Dean.
Okay, and thank you, William.
Yeah.
Okay.
Have a good one.
Everybody, email me your questions, accutone@accutone.com.